Welcome. In this lesson, we're going to be learning how to graph simple exponential growth and decay functions. I call them simple because there's no transformations involved. Right? So first, let's take a little look at exponential growth and decay functions on a graph. But before we do that, you need to learn one vocabulary word, and that vocabulary word is asymptote. Right? So there are three kinds of asymptotes. There's a horizontal, come on arrow, there's a horizontal asymptote, right? So it's approaching a horizontal line. A vertical asymptote, our function's approaching a vertical line, or what's called an oblique asymptote, our function is approaching a diagonal line. We will not be dealing with oblique asymptotes in any part of this lesson, or in any of these lessons. In later lessons, we'll be looking at vertical asymptotes, but for exponential growth and decay, we'll be looking at horizontal asymptotes. There is a space in your notes, it's a few slides down, for the definition of an asymptote, and I'd like you to write that definition in your notes. A line of function approaches as x approaches some value. Right? Could be a horizontal line, could be a vertical line, could be a diagonal line, but in our case, it's going to be a horizontal line. Right? And we'll talk about why exponential growth and decay functions have horizontal asymptotes as we go along. So let's look at some basic facts about exponential growth and decay functions. So first off, exponential growth. This is in your notes completely. Right? So here we have the graph of f of x equals ab to the x, and in this case, in this particular example, a is greater than 1. It does not have to be greater than 1, but b has to be greater than 1 or it's not exponential growth. Right? So some important information about exponential growth graphs. Right? So as x increases, y is also going to increase. As x increases, the slope of the graph increases. Our curve is going to pass through the point 0, 1, but only, I'm going to add a little disclaimer here. I have a equals 1, and let's just make that clear. Only if a equals 1. If a is not 1, it's going to pass through a different point. Matter of fact, it'll pass through whatever a is. Right? So if a is not 1 and a is 2, then it's going to pass through the point 0, 2. Right? And that's because, we'll talk about why. Actually, I didn't want to lock that. I don't know what happened there. We'll talk about why as we go to do some graphs. The curve is not going to cross the x-axis on any of these simple graphs that we're going to be doing. It's going to get closer and closer to the x-axis as we take smaller and smaller x values. So we're going to have a horizontal asymptote, and that horizontal asymptote, ooh, my arrow got stuck there. My horizontal asymptote is going to be at y equals 0. That's where the horizontal asymptote will be. Right? The domain of all exponential growth functions is negative infinity to infinity. Matter of fact, the domain of all exponential functions is negative infinity to infinity. In other words, your exponent can be any real number. It could be a fraction. It could be negative. It could be positive. It could be very small. It could be very large. Anything at all. It could be 0. Anything. The range is going to be 0 to infinity for our exponential growth equations and our exponential decay. We're going to have a range of 0 to infinity. The reason is we're raising a number to a power. We're only going to get positive numbers, right? We're raising a positive number to a power. We can only get positive numbers. That's why our range is 0 to infinity. There's no way I can raise a positive number to any power and get something negative. Right? If I raise it to a negative exponent, it'll get smaller and smaller. Right? But it will never be negative. And that's why we have a restricted range here. And that's why we have a horizontal asymptote. Right? Because there's no way to raise positive numbers to any power and get anything but a positive number back. And you have this in your notes. You also have exponential decay, right? Same information, right? And this time f of x is going to get smaller as x gets larger. Again, horizontal asymptote, y equals 0. Domain, negative infinity to infinity. Range, 0 to infinity. Right? And that's going to be true anytime a is, I don't know why it has, I don't like it like that. Let's write it as y, or f of x equals. Add just this part to your notes next to it. We usually refer to a as being the starting value. Let's write it as f of x equals a times b to the x, right? Because our starting value is not necessarily going to always be 1, right? So in this case, it's b that's going to be between 0 and 1. A can be anything. What we have shown here is a being a number that is greater than 1, but a could also be less than 1, and we're going to see what that looks like in a moment. Right? So you have this in your notes already. So here, I think this is the slide that has them all together. Exponential growth and exponential decay. There we go. This box summarizes the general shapes of exponential function graphs. All right, so these are all 4 shapes. Regardless of the shape of the graph, the domain is all real numbers, or negative infinity to infinity. Any number can be substituted for x, the exponent. Right? On the left-hand side, we have exponential growth. As x increases, the graph moves away from the horizontal asymptote. I have that written in your notes. That's what's going to be the key for growth. Is it moving away from the x-axis? Is it moving away from the horizontal asymptote? For y equals ab to the x, if b is greater than 1, then these graphs will have one of these 2 shapes. The blue graph is if the starting value a is greater than 0. Let's just kind of put that in your notes here, that a equals starting value, just to remind you. Right? So if a is greater than 0, you have a positive starting value, you're going to be on the positive side, because b to the x has got to be positive. And if you multiply a positive number times another positive, you're going to get a positive number. So we're going to be above the x-axis. If a is less than 0, you're going to be below the x-axis. Because b to the x is positive, you multiply a positive by a negative, the result's going to be negative. Right? But if you're moving away from the horizontal asymptote, it's growth. If you're moving towards the horizontal asymptote, it's decay. Right? So for y equals ab to the x, b is going to be 0, between 0 and 1. Our graph is going to have one of these 2 shapes. If a is greater than 0, you're going to be above the x-axis. If a is less than 0, you're going to be below the x-axis. Because no matter what, b to the x is always positive. Right? So make sure you know your 4 basic shapes of your exponential functions, and what the 2 shapes are for growth, and what the 2 shapes are for decay. Right? Now that we've looked at our graphs, now we can do some graphing. Right? In this particular lesson, we are only going to be graphing very simple exponential growth and decay functions. Right? We're just going to have y equals ab to the x and nothing else. Nothing added to the function, nothing added to the x-axis, the x value, right? Nice and simple. Right? So an asymptote's a line that graph approaches as the value of x gets very large or very small. This is for a horizontal asymptote. I had you write in the other definition because later on we'll be looking at vertical. Much later on, we'll be looking at vertical asymptotes. So in this particular lesson, we're dealing with horizontal asymptotes. Right? So it's going to be what happens is either x gets very small or very large. Right? We're going to see our horizontal asymptote as x gets very small for exponential growth, and as x gets very large for exponential decay. So to graph a simple exponential function, you're just going to choose several values of x and generate ordered pairs. Plot the points and connect them with a smooth curve. Always find the y, and this is all in your notes, always find the y-intercept, find y when x equals 0, and choose both positive and negative x values. Use as many values as you can. Right? Minimum is 3, but if your graph is not growing very quickly or decaying very quickly, then I want 5. Right? You'll get the hang of it real quickly. Right? I'm not expecting you to graph numbers that are extremely large, right? But there's no reason you can't graph up to at least 10 or 15, depending on our coordinate plane. Right? So y equals 0 is going to be a horizontal asymptote for all of our simple exponential functions. Right? These are exponential functions which have not been transformed in any way, shape, or form. Right? Just basic exponential growth and decay. And you're going to see these go by pretty quickly. My introduction to them probably took longer than it's going to take me to graph them. All right, so we're going to graph y equals 2 to the x. All right, so table of values. This one's not growing that fast. All right, so we can use, we want to use some negatives. Let's go down as far as -2, -1, 0, 1, 2, and let's also get 3 in there. 3 will actually fit on this particular graph. There we go. All right, so we have, and so this is in your notes, 2 to the -2. All right, if you raise something to the negative power, it makes it the reciprocal. All right, so this is going to be 1/2 squared, which is 1/4. Right? Do write all of this in so you get the hang of negative exponents. Some of you are confident on it, and some of you are a little shaky. All right, so 2 to the -1 is just going to make it the reciprocal. That's going to be 1/2. Anything to the 0 is 1. That's why we get the point 0, 1 on our exponential growth and decay functions. Let's write that in. Why is 0, 1 a point? Any value raised to the 0 power equals 1. 2 to the first, of course, is 2. 2 squared is 4. 2 cubed is 8. All right? I have to stop at that point because I'll run out of space. Okay? We're going to have a horizontal asymptote at y equals 0. I'm going to move this down a little bit. HA, we're going to abbreviate. That just stands for horizontal asymptote. And it needs to be an equation. Don't just write 0. All right? No, my horizontal asymptote is 0. That's not an equation. Y equals 0 is the equation of a horizontal line. Why do we have a horizontal asymptote at y equals 0? 2 to any power is always positive. Matter of fact, any positive number to any power is always positive. That's why we have a horizontal asymptote, because whatever b is, b to the x is always something positive. Let's graph our horizontal asymptote, and because we want to make sure we don't cross it by mistake. Right? We're just going to graph it as a dotted line. That's telling us don't go past that point. Right? That's just the equation y equals 0. Now let's graph our points. All right, so we have -2, 1/4. That would be about right there. Oops. Well, my pen was pointing at the right spot. It should be a little lower than where the pen ended up writing. But my dot is huge. All right, so then we have -1, 1/2, 0, 1, 1, 2, and 2, 4. I wish I had oriented before I started graphing, but I think it'll be okay. All right, so that red line there tells you do not cross. It's going to keep getting closer. All right, that glitch is just the glitch in the board. All right. Oops, we forgot to graph one of our points. We forgot all about 2, 8. Excuse me, 3, 8. Let me fix that. 3, 8. All right, now we'll continue. There we go. All right. It is going to keep going. Right? On the left-hand side, it's going to get closer and closer to 0. On the right, and the left-hand side is getting closer and closer to 0. On the right-hand side, it's getting larger and larger. Right? I'm going to practice too end behavior on all of these graphs. So let's just add in the end behavior. Or maybe not all of them, but maybe on these simpler graphs. All right, so our end behavior, our function approaches not infinity, but it's approaching 0. As x approaches negative infinity, we're getting closer and closer to 0. But as x gets larger and larger, our function is going to approach infinity. So on the right-hand side, it's going to keep increasing. On the left-hand side, it's not going to cross that line, y equals 0. Our domain, the domain of this particular function, y equals 2 to the x, it's all real numbers. That's going to be the domain for every single one of these exponential graphs. It should be super easy to remember. Now it looks a little bit better. The range is going to be 0 to infinity. Parentheses for both, right? Because we don't actually reach 0. Oh man, that is just an awful looking infinity. Some kind of glitch up there. Let's try to write it down here and move it over. Right? There we go. And so as a reminder why there's a parentheses, let's write in. Graph approaches but never reaches 0. And there we go. So now we've already learned a lot about exponential growth graphs with one single graph. Right? We've learned about horizontal asymptotes, about end behavior, right? Lots of stuff. All right, let's graph a few more. Some of these will be growth, some will be decay. I think almost all of these are in your notes. Whatever I write up here, you write up here. Simple. If a graph isn't in your notes, then you can skip that one, but I don't even know if I skipped any of them. All right, so we want to graph y equals 1/4, 2 to the x. On all of these, by the way, we'll be creating a table of values. Later on, we're going to just create a table of values for our basic graph, because it's really easy to figure out what values I should plug in there. And then we're going to learn how to translate our basic graph. All right, so I got a 1/4 there in front. So this is going to get small really quickly on the negative side. So we have to use at least one negative number. I think I will leave off the -2 because of that -1/4. So we have -1 times 2 to the -1 makes it the reciprocal. So that's going to be -4 times 1/2. So that's -1/8. So you can see why I decided to start with -1, right, and not -2. If that had been a 4, I probably would have started with maybe -3, -4, right? But not with a 1/4. Right, 0. So I have -1/4 times 2 to the 0. We know 2 to the 0 is 1. 1 times -1/4 is still -1/4. Right, so now, instead of having 0, 1, we have 0, -1/4. Right? It's going to be whatever our starting value is. Right? Because that's the value when no time has gone by. This is our starting value. Okay? So now we have 1 -1/4 times 2 to the first. That's just going to be -1/2. Right? So, right, you just -1 times 2, 4 times 1, 2/4, 1/2, -1/2. All right, squared. Now, because of that 1/4, I'm going to use 3, I'm going to use 4, I'm going to use 5, but that's it. So now I'm using more values because that 1/4 is making this graph grow so slowly that I can get lots of values in, and we should, otherwise our graph might be a little bit distorted. It's a lot easier just to have more values. All right, so -1/4 times 2 squared. Actually, I probably went, no, I think I can get all the way up to 5. So that's going to be negative 1/4 times 4. We finally got to negative 1. Negative 1/4 times 2 cubed. That's going to be negative 1/4 times 8. That's going to be negative 2. Right? 8 divided by 2. 8 divided by 4 is going to be 2. And of course it's negative because of the negative 1/4. Negative 1/4 times 2 to the 4th is going to be negative 1/4 times 16. That's negative 4. See how slow this is growing? Negative 1/4 times 2 to the 5th is negative 1/4 times 32. And that's going to be negative 8. You're going to be very good at raising numbers to a power after this. All right, so we're going to graph all of those. We want to graph as many as we can. Right, but I'm obviously not going to plug in 6 because I'm going to go off my graph here. And anything less than negative 1 gets to be really small. All right, let's see how we can graph this. So that's our horizontal asymptote. Okay, so on all of these basic graphs, our horizontal asymptote is y equals 0. So do not cross that line there. All right, so do not cross. All right, so roughly that's an 1/8. If I make it go a little lower, it gets really close to the y equals 0, but a little bit more. All right, at 0 we had a 1/4. Tell you this graph is going to grow slow. A 1/2. At 2 we finally got up to, oops, I'm sorry. I forgot we're negative. Ignore that. And there we go, we're on the negative side. And why are we negative? Because A was negative. All right, so now this is negative 1/2. At 2, we finally got up to negative 1. At 3, we were at negative 2. Right, so notice our base is 2, so we're going to be doubling each time. So at 4, we're at negative 4. And at 5, we're at negative 8. Right? So it took a while, but now the graph is starting to grow a little faster. But look at how slow the growth is in the beginning, because you're doubling very small numbers. Now it's starting to grow a little faster. It's doubling each time, but because of that 1/4, it takes a little while for the numbers to get larger. Domain is going to be all real numbers, or range. Now we're reflected over the x-axis. Right? So our range is negative infinity to 0. Oh, I had a place for the horizontal asymptote over here, I forgot. Our horizontal asymptote is y equals 0. All right, and let's talk about our end behavior. We'll write it up here because there's lots of room up here. End behavior. All right, so f of x approaching 0 as x approaches negative infinity. Right, we're getting closer and closer to y equals 0. And as x gets larger and larger, we're going to approach negative infinity as x approaches infinity. Right? For our exponential growth graphs, on one side, either as x approaches positive infinity or as x approaches negative infinity, one of them is either going to be going to infinity or negative infinity. Right? It depends. If we're reflected over the x-axis, for one of the two end behaviors, we're going to go to negative infinity. Right? If we're not reflected over the x-axis, then for one of the two, we're going to go to infinity. All right, let's try another one. And I have end behavior at the very end of all of these lessons, but I thought, it would be a good idea to go over it as we go through them. And this one's also going to be reflected over the x-axis because we've got negative 2 as our starting value, right? A is negative 2 here. But our base is 1/3, and so this time it is decay, right? Because our base is between 0 and 1. All right, so now as x gets smaller, our function's going to get larger. But we got that 2 in front there, so I can't get too large. Matter of fact, negative 1 is going to be it. If I even try to use negative 2, we're going to be off that graph there. Right, so we have to graph at least one negative no matter what. But in this case, it's probably that's all we're going to really fit. And then 0, 1, and we'll go 2. Right, we'll graph 4 points. All right, so this time not as many because of our rate of growth. And our a value is greater than 1. -2 times 1/3 to the -1. Okay, we're just going to make that reciprocal. So that's going to be -2 times 3. That's going to be -6. And you can see that's all I'm going to get because 1/3 to the -2 power, that would give me 9. And that's going to be way off this graph. -2 times 1/3 to the 0. Anything to the 0 is 1, so that's -2. All right, so you're always going to have 0 and whatever your starting value is as a point. -2 times 1/3 to the first power, that's just going to be -2/3. And -2 times 1/3 squared is -2 times 1/9, -2/9. Right, we'll go that small. For all of these simple graphs with no transformations, our horizontal asymptote is y equals 0. Let's graph that. I'll graph it in red, and we're not going to cross the, actually I'll graph it in yellow. That'll show up nicely on the black there. And don't cross that line. This time we're reflected over the x-axis again. Right, so we're going to graph -1, -6. Right, so now you see, now this one's decay, so we're going to grow towards our horizontal asymptote, towards the x-axis. And then we have 0, -2, and 1, -2/3, and then 2/9, right? Which is like a smidge less than a third. Right, so now we're growing towards the x-axis. Our range is going to be -∞ to 0 because we're reflected over the x-axis. Let's also figure out our end behavior. Right, so f of x approaches what as x approaches -∞? All right, this time we're not approaching 0. We're approaching -∞, right? Because we are decay, right? As x gets smaller, we're moving away from the x-axis, which is also our horizontal asymptote. And then our function approaches 0 as x approaches infinity. Right? And that's our, oops, that's right, end behavior. And that's our end behavior. And there we go. As always, if you have any questions, let me know in class. Let's graph a few more. Let's see if I can get this all in. I don't think I can get it in under 30 minutes, but maybe not too much over 30. And here's our next one. All right, so f of x equals 3 times 2/3 to the x. Right? So our starting value is 3. It's kind of large. Again, we're decay, right? Because b is between 0 and 1. Let's take -2, although I'm not, no. If I had trouble with -2 on the last one, I'll probably have trouble with -2 on this one too. Let's take -1, and then we'll see what it is. We can always plug in -2 afterwards. 0, 1, and 2. That's probably good. All right, so 3 times, so sometimes when I see my values, I go, oh, well, I can't get that on my graph here, so I'll skip it. And sometimes I say, oh, I should have plugged in one more value, and I do. All right, so that's going to give us, we're just going to make that the reciprocal because we're raising it to the -1 power. So that's 3 times 3/2, and that's 9/4. I wonder if I can get another one in. All right, so if this were, I'm just going to write this up here so I can figure it out. If it were 3 times 2/3 to the -2, that would be 3 times 3/2 squared. Can we fit that in? That would be 3 times 9/4, 27. Oh, yes, we can. Let's get that one in. All right, now I won't go over it so quickly. We can fit in -2, so let's do that. 9/4, that's not very big. That's 2 1/4. kind of wasn't thinking there. If my base is larger than 1/3, it's going to decay. The decay won't be as rapid. And so we can get the -2 in there. 3 times 2/3 to the -2. We can put that in. That would be 3 times 3/2 squared. All right, and so that's going to be 3 times 9/4, and that's just 27/4. That's a 4. All right, that's just that's not even 7. We can fit that in. 3 times 2/3 to the 0 is just going to be 3. 3 times 2/3 to the first power is going to be, well, it'd be 6/3, which is just 2, right? The 3's would cancel. And then always make sure you keep going until you get less than 1. 3 times 2/3 to the second power is going to be 3 times 4/9, right? And that's still not going to be less than 1. That's going to be, so we can reduce that there, right? And that's going to be 4/3, still not less than 1. One more. This should do it. 3 times 2/3 cubed. That's going to be 3 times 8/27. Right, we can reduce there. And just barely less than 1, 8/9. Good enough. All right, so there's our points. All right, our domain, of course, is all real numbers. Let's move that over a little bit. Horizontal asymptote at y equals 0. For all these simple ones, it's y equals 0, whether it's growth or decay. All right, and then we'll graph our points. So we've got -2 27/4. So that is 6 3/4. -1 9/4. That's 2 1/4. Oops. And then we've got, wait a second. There's something wrong here. Can't be 2 1/4. Did I have an error there? 9. Oh, 9/2. I have no idea. No idea how that became a 4. 9/2, which is 4 1/2. Right, so now it's okay to make a mistake, but when something doesn't jive, don't just graph it as though it does. Right? It's got to be more than 3. Right? It can't jump up and down. Right? It's just going to gradually decrease. And then 1, 2, and 2 was 4/3. That's, whoops. You move over. You're not in the right spot. 2 is 1 1/3. That's what 4/3 is. And then just barely for 3, just barely under 1. There we go. Here's our graph. So that rate of decrease at the end there is a little slower the larger your base is, and faster the smaller your base is. All right, our range is going to be 0 to infinity. We're above the x-axis. All right, and let's write our end behavior real quick. Right, so our end behavior here, because this is going to be good practice. And by the way, it's a lot easier to figure out end behavior if you have a graph. For these f of x approaches, so as we're approaching negative infinity, our graph is approaching infinity. So f of x approaches infinity as x approaches negative infinity, right? Because as x gets smaller, our function's getting bigger. And f of x approaches 0 as x approaches infinity. As x gets larger, our graph is headed to 0, and it will not cross. No way, no how. All right? And how many do I have? If I have more than, I have 1. Is that my last one? Hello? Let's see if it's the last one. Yes, it is. Let's graph the last one. If this was more than one, I might have made this 2 podcasts, but we just have one more. So anyway, you can see you have this in your notes. There we go. F of x equals 2 to the negative x. This can be rewritten as f of x equals 1/2 to the x. Make sure you rewrite those negative exponents if you have some. All right, so we can go to -3, right? Because this is kind of the decay version of f of x equals 2 to the x. For the growth, we could use 3. For the decay, we could use -3. -2, -1, 0, 1, and 2. All right, so 1/2 to the -3 power. That's just going to be 2 cubed, right? Flip it, change your exponent to positive. That's 8. 1/2 to the -2 power is the same as 2 squared, so that's 4. 1/2 to the -1, just flip it so that it's 2. Anything to the 0 power is 1. 1/2 to the first power is 1/2. And 1/2 squared is 1/4. I decided to use parentheses for some reason on the last one. Yeah. Make them all feel good. We'll all use parentheses. All right, so here our starting value is 1, right? That's why we're going to go through the point 0, 1. Horizontal asymptote is y equals 0. There we go. We'll cross that line. No way, no how. And let's graph our points. So -3, 8, -2, 4, -1, 2, 0, 1, and then 1, 1/2, and 1/4. So as time goes on, it will get closer and closer and closer and closer to this line, although I really can't draw it looking closer and closer because, well, my pen has some ink, has some width to it, but that's the idea. It's going to keep getting closer. Our domain, as always, for all of our exponential functions, all real numbers. The range, we're above the x-axis, so it's 0 to infinity. Let's do the end behavior so that we get good at this. All right, so f of x approaches positive infinity as x approaches negative infinity. It's growing as x gets smaller. And f of x approaches 0 as x approaches positive infinity. It is heading to 0 as x gets larger. And that's the end of this podcast. Thanks for watching, and bye for now.